Welcome to the fog.
Hi world. Welcome to my channel. In today's video, I wanted to assemble a simple wireless temperature sensor that is based on the AVR ATMega328P. The example shows how the sensor sends temperature data to the display using 433 MHz wireless communication. Temperature measurements are performed using a digital thermometer DS18B20. Temperature measurements are displayed on LCD NOKIA 5110. Using one microcontroller to control the transmitter and one microcontroller to control the receiver. I am going to use 433 MHz wireless transmitter and receiver set. Device includes the following base electronic elements. Microcontrollers AVR ATMega328P. The device uses the following peripheral features of microcontroller. The transmitter and receiver are connected to the microcontroller via the universal asynchronous receiver and transmitter. UART capability of the ATMega328P allows you to easily communicate the microcontroller with other devices that support UART. It is the primary interface to many other devices, such as GPS receivers, other microcontrollers. Serial peripheral interface for display interfaces to microcontroller. SPI is a useful data transfer protocol for microcontrollers. Unlike UART, SPI is synchronous, meaning data transfers are synchronized to a shared clock signal between the two communicating devices. This significantly simplifies the implementation at a hardware level, requiring little more than shift registers, and also means that the baud rate between devices does not have to be agreed on beforehand. 16-bit timer counter interrupt for counting of time. Pair of 433 MHz modules. FS1000A, the transmitter. Working voltage, 3 to 12 volts. Higher voltage it's more power, it's more range. Current while transmitting, 28 milliamperes. Range, up to 200 meters. Data speed, up to 10 kilobytes per second, but range drops considerably with speed above 2400 bit per second. ZMK 5 volts, the receiver. Voltage, 5 volt. Very sensitive to voltage fluctuations. Always use stabilized power source and decoupling capacitor. Current while standby, 4 milliamperes. Monochrome graphic display Nokia 5110 with internal controller driver PCD8544. The PCD8544 is a low-power seamless LCD controller, driver, designed to drive a graphic display of 48 rows and 84 columns. All necessary functions for the display are provided in a single chip, including on-chip generation of LCD supply and bias voltages, resulting in a minimum of external components and low power consumption. The PCD8544 interfaces to microcontrollers through a serial bus interface. Programmable resolution 1-wire digital thermometer. The DS18B20 digital thermometer provides 9-bit to 12-bit Celsius temperature measurements. The DS18B20 communicates over a 1-wire bus, that by definition requires only one data line, and ground, for communication with a microcontroller. Applications that can benefit from this feature include VAC environmental controls, temperature monitoring systems inside buildings, equipment, or machinery, and process monitoring and control systems. To create a wireless temperature sensor, I have developed a circuit diagram that looks like this. I wrote C code programs for transmitter and receiver microcontrollers. My explanation of the code will not be detailed, and if you have any questions, please leave them in the comments. The link to the circuit diagram and source code is in the description. You are allowed to download them, but give me like and comment, please. Wireless temperature sensor code. Tell the compiler at what speed our chip is running so that it can calculate delays properly. Define desired baud rate. Defines communicate parameters. Declaration the variable as a sensor checking flag. Next, include the preamble, which is where we put our include information from other files, which defines global variables and functions. Header to enable data flow control over pins. Header to enable delay function in program. And header to enable interrupt function in program. The procedure to microcontroller UART interface initialization. The function to transmit byte of data through UART interface. The function to send packets of data. (16-bit) timer initialization. The procedure set up the prescaler chip timer to 256 and turn on mode by clear timer on compare. Counter initialization. Set output compare register to 62,500, so corresponds 1 second of timer. Enabling output compare match interrupt enable bits. It ensures that an interrupt is fired whenever a match occurs. In the AVRs, there's only one single bit which handles all the interrupts. Thus, to enable it, we need to enable the global interrupts. This is done by calling a function named s. Whenever a match occurs, timer counter becomes equal to output compare register, and interrupt is fired. Temperature sensor initialization function. The port is being configured to connect the temperature sensor to pin 2 of the microcontroller port D. The function returns 0 if the sensor is plugged. The function to read a byte from the temperature sensor. The function to write a byte to a temperature sensor. The procedure reads temperature sensor data and sends it to a receiver that displaying measurements on LCD. Interrupt service routine to attend to the timer interrupt. The interrupt is fired regularly every 1 second to read temperature measurement. The main function is where the AVR starts executing your code when the power first goes on, so it's the entry point of the program. This is where the initialization functions for UART, temperature sensor, and internal 16-bit timer. Also here looping, often referred to as the main loop or event loop. This code is always true, therefore, it executes over and over again in an infinite loop. The next step is building the project. It means compiling and finally linking all object files to generate the executable hex file. This hex file is generated inside the folder debug, which is inside the project folder. Now, view the code for the receiver microcontroller. Tell the compiler at what speed our chip is running so that it can calculate delays properly, as usual. Defines pins of the chip I/O ports to display connecting via serial peripheral interface. Defines pin of the chip I/O port to display reset. Defines pin of the chip I/O port to select the display mode. The hex codes array to show a minus symbol on the display. Initialization of the hex codes array of numeric characters to show on the display. The hex codes array to print temp word on display. As usual. Header to enable data flow control over pins. Header to enable delay function in program. And header to enable interrupt function in program. Defines desired baud rate. Defines receiver communicate parameters. The procedure to microcontroller ports initialization and global interrupts enable. Set up port B as a serial peripheral interface for display connecting. The procedure to serial peripheral interface initialization. The next two procedures turn the display on and off. The function to transfer data to the serial peripheral interface for displaying to LCD. The procedure to reset the display. The function to transfer command data to the serial peripheral interface for display control. The procedure to display initialization. The procedure to clear display. The display clearing procedure will be to transfer zeros to the address area of the display matrix. The procedure sets the current position of the pointer at a matrix of the display to X and Y coordinates. The procedure transfers minus symbol hex codes to the display. The procedure to clear a numeric character on display. The procedure transfers hex codes of the numeric character to the display. The procedure to microcontroller UART interface initialization. the function to read the value out of the UART buffer. The interrupt service routine of the receiver to receive data from the temperature sensor and show it on LCD. The procedure transfers hex codes of the temp word to the display. The main function is where the AVR starts executing your code. This is where the initialization functions for ports, interfaces, peripherals and display launching. Also, it contains a main infinite loop. The main endless loop state is empty. Interrupts are working. Building the project to generate the executable hex file to the receiver chip. The hex files of the receiver and transmitter are ready to be loaded into the chips. I burn the program into the memory of the ATMega328P microcontroller using a Verdute software and an ISP programmer. OK. Now, the device works in accordance with the instructions of the programs. Let's check it out. Thank you for watching. See you later. You can help me by sharing this video if you like it. Please like, comment and subscribe. Bye.